The last time we did any overclocking content on the channel wasn't actually all that long ago. However, in that video, we really skewed more towards the extreme end of things than the mainstream side. After all, we were using an 18-core 7980XE, we were cooling it with an air conditioner and a full custom loop, and that setup is really applicable to, well, I guess really to nobody. So what I wanted to do today was show you guys how you can take advantage of performance that you have already paid for and unlock the potential of a chip like a 9900K. Ready to dive into custom water cooling but unclear about what parts you might need? Check out Thermaltake's new M360 Plus RGB kit. Featuring a D5 pump res combo, 16mm hard tube, Pacific C Pro fittings, and the best RGB implementation on the market, the M360 Plus fits all mainstream Intel and AMD sockets and is fully expandable as your system evolves. Check out the link in the video description to learn more. Before we even attempt an overclock on a processor like a 9900K, it's important that you have the right components in place even before you turn your system on. Today we're going to be using the Z390 Aorus Master from Gigabyte. This is a really good high-end Z390 board. It's got probably overkill power delivery. It runs on two EPS 8-pin connectors, which again is probably overkill. It has an actual finned heatsink over the VRMs, making sure that everything stays cool. And I've done some overclocking with this board already, and I've never been disappointed. It definitely holds up. It's definitely stable in multiple different states with multiple different chips. And it's definitely a product that I would recommend if you are looking to do high-end overclocking on a chip like a 9900K, which really needs all the power delivery, all the stability, and all the heat dissipation that you can give it. Other motherboards in this vein that will likely be able to provide you with similar results include the Asus Maximus 11 line, specifically the Code, the Formula, boards like that. Also, MSI put out a bunch of new boards under the MEG or MEG line. Their Godlike board is a $600 mainstream motherboard, which is probably something that we've never even really seen before. But again, overkill on the power delivery, overkill on the cooling. And if you're going to be pushing an 8-core 16-thread chip like a 9900K, these are the things that you need to have in place before you even start. Otherwise, you could run into stability issues that actually have nothing to do with the performance of the CPU itself. You could have VRM overheating, you could have instability with memory, and you don't want to have any of that in your way when you're trying to achieve maximum performance. Obviously, also, you are going to need a good cooler. Now, on my test bench over there right now, I have hooked up the Corsair H150i Pro. It is a 360mm all-in-one liquid cooler. I would recommend, if you're going to be overclocking 9900K, that you go with something similar. I think probably the least amount of cooling you could get away with is something like a 280mm if you're going to be pushing to 5 gigahertz and beyond on all 8 cores. If you're not going to be overclocking 9900K, you could probably get away with something like a high-end air cooler, or 240mm AIO is probably fine. But the heat really starts to build up quickly, and you're going to need a way to dissipate it once you start pushing those cores up beyond 5 gigahertz. So once you have all your gear in place and you're confident that your setup can handle an overclocked processor, the first thing that you should do before dialing in anything is to establish a baseline. So let's take a look at our desktop and we'll see where we're at before we change anything in the BIOS. So right now, this is CPU ID Hardware Monitor. This is a good program to get to know if you're going to be doing overclocking, because it does give you a lot of diagnostic information, including the voltages that you're running at. Right now, the way that the BIOS comes, the Gigabyte BIOS, is set up with auto voltage, and a lot of motherboards are going to be very similar. So you're going to see a lot of fluctuations in this voltage number right now. Before we change anything, because it's not set to anything in particular. And also, when we put it under stress, you're going to see that it jumps up pretty high. Right now, our CPU is running in the 20s on the package, right now 28 degrees. This peak temperature, this happened when I opened Hardware Monitor and put a tiny load on the processor. And you could see that things jump up really quickly, even if you're really not doing a whole heck of a lot. And then we have our utilization. This is useful when you're running stress tests to see if all cores are pegged or if tests are only using certain cores. And then we have our clock speed. So the 9900K out of the box does allow up to 2 cores to boost to 5 gigahertz, but but the rest are on a frequency stepping table down. So you're going to have 2 cores at 5 gigahertz, and I don't know the exact table, but I think the next 2 cores are at 4.8, and then 4.6, and then 4.4, or something along those lines. It does not allow all cores to boost to 5 gigahertz all the time, and this is what we're going to be trying to change. So down here we have the rest of the system information, and this is mostly irrelevant for the purposes of our testing today. We're going to be focused on this area up here. So let's get a baseline Cinebench run. We'll see where we're at, and then we can see how much better we can do once we get our overclocks in place. So we've got 2029. This is a fairly typical number for a stock 9900K. If we go back to hardware monitor, we could see that we peaked up in the 80s as far as temperatures go, and you can see that our processor utilization was all the way up at 100%. And then at one point or another, every one of our 8 cores hit 5 gigahertz. But what we're going to do is we're going to reset. We're going to get into the BIOS, and we're going to make some changes. Okay, here we are in Gigabyte's BIOS, and just by hitting enter on the very first entry, we get a lot of information on our CPU and see how Gigabyte has configured the BIOS and configured the 9900K to run out of the box. Now, this isn't necessarily something that you need to do, but when I do overclocking, I disable what's called multi-core performance or multi-core enhancement on some boards. This is something that is almost like an auto overclock. It's not going to give you the full overclocking experience that you would see with that we're going to be trying to go for here. But at the same time, if you leave this on and you change your multiplier, you're probably going to end up with voltages that exceed what we really want, and you might run into stability issues if the multi-core performance is pushing the chip too high. So I like to disable this so that I'm in control. And this is the setting that you really need to worry about when we're talking about overclocking. So you need to take into consideration 2 factors when you're worried about how fast you're clocking your CPU. The first is the base clock. You can see right here that at auto it's set to 100 megahertz. This is by default what the vast majority of processors on the market use, is a base clock of 100. You can change this. And usually what I will do is, this is kind of a last resort. If I'm trying to push higher, I use the base clock. If I've hit a wall with the clock ratio, but for the most part, I just leave it at 100. I find that CPUs like 100, and they're much more stable at multipliers of 100. And then the second factor is ratio. So this is what's going to tell the CPU, it's a multiplier basically. It acts on the base clock. So right now you can see that our clock ratio is set to auto, which defaults to 36. So the base clock of a 9900K is 36 times 100, or 3.6 gigahertz, which it tells you right here, right underneath. So if we want to change this and we want to go for 5 gigahertz, because that's a reasonable overclock to try to achieve with the 9900K, which already has a couple cores boosting up to 5 gigahertz. So in order to get to 5, what we want to do is we want to put a multiplier of 50. Now 50 is going to take 50 times 100 is going to take us up to that magical 5 gigahertz number. But we don't want to stop there. We want to make sure that our memory is also running at its rated speed. The easiest way to do that is to use the XMP profile. Go down to XMP, switch it from disabled to profile 1, and you can see that automatically takes us up to 3200 megahertz. We have a 2x8 gig kit of Patriot 3200 speed memory. Now there's obviously other things that we can change in here. Most notably is voltage. So what we want to do is go down to the CPU core voltage, and I'm going to give you a little bit of behind the scenes. I've already kind of cheated here, and I kind of took the pain out of watching me fiddle around and figure out which voltage is best. But what you likely will need to do is figure out the lowest voltage that your CPU will be able to run and complete all kinds of stress tests with at your desired frequency. You do not want to run it at a higher voltage if you can avoid it. More voltage is more heat. So right now we're in the Gigabyte BIOS, the CPU V-Core is what we're worried about. And you can see, like we mentioned before, it's on auto. So right now it's running at 1.2, but it does go up higher than that if the motherboard feels that we need to. but the 9900K, or at least my 9900K at 5 gigahertz, is stable at 1.375 volts. So we'll dial that in. Now, the rest of these we're not going to worry about for now. These get more into the advanced part of overclocking, applying voltages to different parts of the board, different components, as well as there's also some additional frequency settings that we can dive into. Again, like things like the AVX offset are important if you're running AVX tasks, but we're not going to worry about that right now. We're just going to go with base clock and voltage as the main things that we really need to worry about when we're doing overclocking of this nature. So we're going to save and reset. We're going to boot back into Windows, and we're going to see what we did and what the results are. So we booted back into Windows now, and you can see that we are running at 1.3. This is reporting 1.38 volts, but this is our 1.375 that we dialed in. The temperatures on our chip are a little bit higher. Even at idle, this was in the mid to low 20s before. Now we're running in the low 30s. And this, again, these temperatures are just from opening up Hardware Monitor, so a tiny load gets us already up into the 40s. So you can see even with a 360 millimeter radiator, we're already pushing up a little bit warmer. Again, our utilization is what we're going to keep an eye on, make sure everything is hitting 100 when we want it to. And then our core clocks. You can see that every one of them has already touched 5 gigahertz because that was what we are clocked at. So let's open up Cinebench. And you can, well, let me actually minimize this or take this down a little bit so we can watch both at once. So let me slide that over. And when we run this, you're going to see that all cores are going to go to 5 gigahertz. All utilization is going to go to 100. And if I make this bigger, maybe we could actually also see our temperatures at the same time. All right, so let's keep an eye on a couple things. We're going to look at the core temperatures, we're going to look at the frequency, and we're going to look at the utilization. So our temperatures are automatically going all the way up into the 80s. Utilization on every core and every thread is 100%, which is good. And then all cores are at 5 gigahertz, just the way we wanted it. And then we're going to see a number here that hopefully is higher than what we had before. And yes, indeed it is, 2155. So we could definitely go higher. This cooling solution is pretty beefy. And, you know, the Intel CPUs have a TJ Max of 105 degrees. You don't want to be running at 105 degrees, but the fact that we're at 83 on the package at max means that we can likely push higher than 5 gigahertz if we wanted to and still be within spec. But we're not going to do that today. We're going to keep it at 5 gigahertz. The Cinebench does a good job of replicating real world stress on the CPU, but and usually I'd find that I'd say maybe 95% of the time, if my overclock can pass Cinebench, it is stable. But if you want to be more thorough and you want to make sure that your CPU is definitely going to be able to survive the rigors of daily use and stress, you can run something like IDA64, which we will take a look at right now. This is IDA64. It has a tool in it that's very useful when determining if an overclock or any system configuration is actually stable. It's called a system stability test. Who would have thought? So all you need to do is hit start, and it starts stressing everything that you've checked here. So the first 4 boxes, CPU, FPU, cache, and memory, are really what we're worried about when we're talking about CPU overclocks. It's also very helpful because it has a chart that'll show you each core temperature. This is the utilization, as well as this line down here will show you any potential throttling that happens as a result of overheating. So usually if you let this run for, let's say, 10 minutes or so, and you're not seeing any throttling down here, because once this graph leaves 0, this number turns red and then the line turns red, so it's very easy to see, and then you will know that obviously you have a thermal issue. But if you run this for, you know, let's say 10 minutes or so, and this line stays at 0, this stays at 100%, and your temperatures stay within reason, you know that your overclock should be good to go. We see our temperatures getting a little bit higher than they were before because system stress tests are always going to work the processor harder than something like a real-world application might. You can see that these are just all pegged at 100% and they won't leave 100%. Unlike if you're doing something like video editing, rendering, stuff like that, you'll see 100% usage, but it'll also drop down. Each core will drop down a little bit at certain times. But this is basically just pedal to the metal, full throttle, system stress. And you can see that obviously we're running at 5 gigahertz across the board and everything appears really stable. I'm not going to let this run for the full 10 minutes, but we haven't seen any throttling so far. Our temperatures are, while higher than before, still hovering within the acceptable range for this kind of an overclock on this processor. I think we're good to go here. So guys, that is the simplest way to get a good overclock on a chip like a 9900K. You're worried about a couple things. You're worried about voltage, you're worried about frequency, and you're worried about multiplier. You also want to make sure that your memory is running at rated speed if you can. That's going to give you a little bit of boost in performance. And as you can see, we achieved 5 gigahertz pretty easily. If you start to try to overclock and you're getting crashes, you're getting instability in your system tests, don't be discouraged. Play around with that voltage, play around with those frequency settings, see if you can achieve stability at one point or another. Most likely, it's going to take you 4, 5, 6 tries before you end up with any kind of a reasonable overclock. And if you're pushing higher than something like 5 gigahertz on this chip, you may end up with crashes 15, 20 times in a row before you figure it out. And that's perfectly normal. Don't be discouraged. Just keep trying at it. These systems are designed with a lot of safeguards these days. So you're not going to be thrashing your chip. You're not going to be breaking anything by doing this. If the CPU doesn't like its configuration, it's just going to shut down. So you're not going to overheat it to the point where it's going to break something. And you're unlocking the potential and the performance that you have already laid out money for, because an overclocked chip is meant to be overclocked. So that's it, guys. Hope you enjoyed this video. Hope you took something away from it. Go out there and do some overclocking. Let me know down below in the comments what kind of speeds you guys are achieving, and I will see you next time.